Hello and welcome to the Teardown Sessions. I'm in a new setup, so please pipe up if you can't hear me or if there's something wonky going on with the sound or the vision. I've moved offices and had to put everything back together again, so do let me know if you can't hear me. Today we are having a very special guest. We have got Nick from BeanCounter and SparkFun fame. He is here to give us an update on how his manufacturing is going and all the exciting things that he's been up to. But before I bring him on, I would like to just share a few things that's going on at Crowd Supply at the moment. Slightly weird the ratio here. Let me just pull that out a little bit. Here we are. So at the moment, crowdfunding, we have the MNT Pocket Reform doing super well at the moment from Lucas from Berlin, who's been doing lots of really awesome open source things. This is a great pocket laptop that has been funding for the last couple of days and has already raised 150K. So check that out. I kind of want one. See how I feel towards the end of the campaign. I might have to get one for travel. Also crowdfunding now, we have got USB serial, which you can see here as a delightful tiny little device here. It's already raised its goal. So if you think that's something that you're interested in, you've got 11 days left to fund that. We've also got Pi EEG, which is an open source Raspberry Pi shield for biometrics, doing all sorts of interesting things like biosignals. And they've been doing, this is a returning team who've been doing awesome things, and this is their latest device. So if you're interested in doing biometric hacking, this is a really good thing to check out. We also have Loud ESP powered audio development program, ESP32 remote, which is a great Home Assistant compatible device. And finally, we have Riot EE, which is an open source platform for Internet of Things. Lovely little module, that one. Check that out. So all of those things are crowdfunding now. Well, without further ado, I'm going to bring on my guest today. Oh, and also I want to give, let me go, bring him on. Hello, Scott. Hello, Nick. How you doing?
Doing well.
Good. Before we start chatting, I want to give a shout out to Microchip, who are the sponsors of today's stream, and also are the sponsors of, not sponsors, they are supporters of Nick Poole's campaign, the BeanCounter, which does use a Microchip device as well. So thank you for sponsoring machine. We very much appreciate your help. So Nick, tell me, how's things? It's been a minute. What's going on with you?
Things are good.
Well, actually, first of all, let's introduce you. Now everybody knows. Go ahead and introduce yourself to people on the stream if they don't know you already.
Totally. I'm Nick Poole. I'm an engineer, electrical engineer for SparkFun Electronics. I've been there since 2011, and I work in the research and development department now. And aside from that, I do a bunch of stuff that isn't SparkFun related, and it's also mostly electronics and just making things. So I have a little contract manufacturing business, and I just last year launched sort of our first product that I designed myself, which is BeanCounter. And we were funded, and I've got all the parts to build everything that I need, and now just doing a lot of hurry up and wait while we compliance test to make sure that we can CE mark and get these things shipped out to people.
How have you been? So when did the campaign end exactly?
It was in the winter, and I can't remember when that was.
Point. Yeah. So talk me through what you've been doing after the campaign. I think a lot of people know a lot about the run up to the campaign, right?
Sure.
So you're doing your prototyping, you're getting your content out there, you're getting your money. But then what happens at the end of the campaign? What did you do? What was the first thing that happened?
Yeah, so a few things happened. The first thing obviously was to go out and pay all of my suppliers and start to get parts in to build all of these. So
did you have any problems sourcing anything, or?
I was a little bit worried going into it that we would have trouble with the IC. The only IC on the whole board is the microcontroller, and we're using AT Tiny microcontroller, and it's sort of a less common one in DIY projects, but it's incredibly common in sort of the automotive industry.
Yeah.
And it, along with, everything else that became unobtainium around the same time, it basically evaporated from the market. But there was always a stash of, a few tens of thousands or a few hundreds of thousands at one or two suppliers at a time. And I knew, best case scenario, I would be looking for, maybe 1,000, fewer than 1,000 probably. And so I was never like too worried. It did look like I might have to source them myself, and then sort of ship them to my contract assembler to do the PCB assembly, because they weren't going to be able to source them. But it turned out that by the time that I was actually ready to order the boards, that part had become sort of easy to get your hands on again, and they were able to source it for me no problem at a pretty reasonable price. So there was never really a concern in my mind that I wouldn't be able to build, but the concern was that I would be able to build, but that line on my build materials would, triple or quadruple in price because of how scarce it had become.
Yeah, for sure.
But, so even though I am a contract manufacturer, I have a full SMT line capable of doing, hundreds of units. I didn't want to.
You mean in your own shop, in your own workshop?
Yes.
Nice.
And because of that, it was very tempting to build all of this myself, just ordering the PCBs, ordering all the parts. But because there are so many other parts to the picture of launching a hardware campaign, especially when it's your first, I did not want to get too distracted with that and then fall off on the other things that need to be done.
That's wise.
And so I outsourced that. I partnered with PCBWay, and they supplied the PCBs assembled to me. And in fact, one of the first purchases I made after the campaign ended was...
yeah, you can open that up.
Yeah, a giant cardboard box full of these individually static wrapped panels of the BeanCounter PCB. So these arrive at my door completely populated. So there's that microchip part that I was so worried about being able to get my hands on. And then some LEDs and some other things. It's a really simple circuit, which is what I like so much about it. And it's only two PCBs that basically sandwich together to create the device. So I have a bunch of these that I worked with PCBWay to have produced.
And how fully assembled are they? Are you doing all of the assembly in China, or are you doing any of it here?
Basically, the final assembly happens here in the US.
Is that a country of origin decision, or is that just you want to have oversight of it?
It's just that I want to be able to do the final step. At some point, I would want to be involved in the quality assurance and the testing.
Yeah, that makes sense.
And so, you can draw the line sort of wherever you want as far as where the thing is put together, but eventually it has to get to me so that I can lay hands on them and make sure that they're good and then ship them out. So I might as well do the final assembly steps myself. And I'm a little bit picky about how that gets done anyway. So
what testing do you get done at the factory versus what testing you get done do you do in your own lab?
The only testing that gets done at the factory is like a flying lead test for the PCBs to make sure that they are electrically sound before they get populated. After that, they do AOI, automated optical inspection, to make sure that the parts are placed correctly. But there aren't any electrical tests, or they don't load any firmware. They come to me.
Okay, so you're flashing everything yourself. You're doing all your tests yourself. Okay, tell me about your test jig decisions. I am currently in test jig land myself. Like, I'm doing some work with Luke Valenti on Tiny FPGA, and we're doing some test jig stuff for that. And I'm like trying to cram as much information into my brain as possible from different creators about how you approach test jigs and what you're doing. So, like, tell me, like, what are they done yet? Have you
Not yet. I have. So one of the things, part of the reason that a lot of things are sort of sitting around, even though I have all the parts that I need to start building things, is because at the moment I am waiting to get the BeanCounter through EMI and EMC testing. I am like.
Where are you doing that? Also in China, or?
No,
here?
I'm actually doing that in the US, and I won't name the test lab because he's been almost too open about the fact that he does not like to work with companies my size or projects like mine. And so,
well, let's not give them any more business then. If he doesn't enjoy working with small
explicitly
people.
asked me not to.
Wow.
Yeah.
Okay.
So,
wow.
the deal is that when I first went into it, and we will circle back around to your original question, but when I first got into this, I was pretty certain that I'd be able to do my own testing, and I bought some equipment to that end and started to get into it, and pretty much decided that it is possible for me to do, but it will cost me to just, if you think about it as an investment for a single product line, it'll cost me the same amount it'll cost me more to build a test lab, right, than to have the testing done, which is why test labs exist. Right. But the upside, of course, is that, once I know how to do it, I could do it on all future products, great big factory products. So what I decided was that I really needed to come out of the gate with testing from a certified lab that I could look at and try to replicate in the home lab. And that way I would have sort of a standard that I could convince myself, like, okay, I get a chart and it has some spikes on it, and the spikes hopefully are all below a dotted red line, right? And then I can do my own spectrum analysis, and I can see if I get the same spikes, right? And then once I know that I can do that, then I can start spending money on buying all of the relevant standards documents, which cost $300 or $400 a piece. I can pay for the calibration of my equipment so that it has a calibration ladder back to a certified lab that follows calibration back to either NIST or a Chinese lab. And then, all of the little odds and ends, all the RF power amplifiers and RF bridges and splitters and filters and things that you need to run those sorts of tests. Like I mentioned, I've already bought some. I bought a little spectrum analyzer, sort of like the lowest end spectrum analyzer you can buy. It's a Rigel DSA 815. It costs like $800.
That's still a chunk of change, though.
It is,
for people starting out.
Absolutely a chunk of change. And if you want to, if you would like to pay the company for the software that makes it do all the things that it should do as a spectrum analyzer for RF testing, that costs more than the hardware itself.
It's one of those. Yes. It's I hate that. That drives me. It drives me nuts when people like software limits the hardware. I'm like, come on, I paid for the hardware. Give me the functionality, for goodness sake.
Yeah,
hardware as a service is like a great evil, in my opinion.
It is. I agree with that, and
it's like don't try and make me subscribe to my physical hardware, please. It's too offensive to me.
so luckily, I mean, if someone was so inclined, they could ground the write protect pin on the EEPROM for that device that it stores all of its trial software keys in, and then the device would forget that the trial was over every time that the trial ends. I'm not saying you should do that, but someone could do that. And
it's a possibility that someone could do that.
Someone
they
could do
should
that if they were in a real pinch and couldn't afford to buy the software. And then I also have a TEM cell, short for transverse electromagnetic cell. It's a type of test chamber for doing RF measurements. And I bought a used one from some company that went under that I think was testing like cell phones or something. and that was, you know, another couple $100 plus shipping from eBay, and is going to probably require some characterization to make sure that it still makes the measurements it did when it was new. All of this is, you can see the rabbit hole that's opening up.
Oh, I absolutely can. I can see it in your eyes as well.
Yes.
Like...
I have no, I hold no grudge against anyone who runs a test lab, because there is a lot of expense in it. And it is, especially, you know, with CE marking in particular, you're not so much paying for liability, because the test lab has no liability. They are giving you test results, and then as the manufacturer, you are actually liable for conforming to the CE. So you write a declaration of conformity and you say it's based on these test results. All that the laboratory is really certifying is that the test results are accurate, not that it meets a certain set of standards. So, but in a lot of cases, they actually do have some liability. And so I understand the expense involved in that. That being said, I think there's probably space for a test lab that only does sort of bare minimum CE, UKCA, FCC Part 15B, like basic EMC, EMI testing.
I do agree with you. It's actually, you know, it's this thing that I would say intimidates creators the most, like first-time creators, like having to deal with testing, and you know, they just don't know where to go. It's a whole world, and you can get things very, very wrong.
Absolutely.
I've got another couple of questions, but before we move on, I actually did want to say hello to a few people in the stream, and also I wanted to announce the giveaway that we're doing today as well. So just to say hello to people who said hi. Hello, Taki B. Nice to see you again. You're often here. Thank you for keeping us company. Deadbug Engineer coming along here to say hi. Hello. Jovan RJ, really great to see you. Jay. Nice to see you. Hopefully see you in New York in person at the Open Source Hardware Conference. Are you going to that, Nick?
Not so far. Not as far as I know.
Yeah. Well,
I'm involved in trying to get SparkFun's badges put together for that. So.
Well, I'll be there anyway. So yeah, hi Jay. We've got Leon and Avi, one of our other creators. Hello, Leon. Always lovely to see you. Thanks for joining us. And then we've got Chip Scribbles, who says, "Oops, my conductive wire slipped onto the ground." EEPROM. Oops.
I hate when that happens.
Very naughty of you. Very naughty of you. Just. So as viewers of the show will know that I often give away little things. Today we are giving away a bean counter, so you will get added to the list of backers who will get their devices when the order comes through, which we'll be talking about that soon, I'm sure, about those days. But today we are going to give away, a bean counter. The way you win that is by commenting, asking questions. Oh, you're Chipperdoodles. Oh, hello, Chipperdoodles. Chip Scribbles. I was like, I wonder if that, I did actually think, I was like, is that Chipperdoodles? Yeah, I did wonder. Okay, yeah, hi, Chipperdoodles. Yeah, so if you ask a question or leave a comment closest to the timestamp that is on this piece of paper, then you will win the bean counter. So just keep your questions coming and comments coming. It does make us feel a bit less alone. Yes, that's it. So thank you for joining us. Say hi if you're in the chat, and ask your questions and comments, and you may indeed win a bean counter. What fun. I also, so yeah, and thank you to Microchip for sponsoring that as well. That's thank you. So now I've announced that and said hello to the people in the stream. Can it count beans too? I don't know. Can it count actual beans? I don't know.
If the beans were very small and you had them,
have you put it inside? Like if you put beans around it.
Yeah, if I had an unlimited packaging budget, I would love to ship them in sort of like steel Heinz beans cans.
That would be great.
With some conductive foam. I think that would be great. That would be
really fun.
Great.
That would be the best. Yeah, so I wanted to ask you, so we've been talking a lot about testing and jigs and certifications and all of this kind of stuff. But I'm very curious because you've worked in hardware before for a long time, working at SparkFun. But is these the kinds of things that you are doing battle with in your day job as well, or is this the kind of stuff that you really? This is kind of like stuff that you get into when you are the creator, What's
Yeah.
it? What do you is it been a big learning curve for you, even though you're an experienced hardware creator?
So sort of circle back to your earlier question about testing and test jigs.
Yes.
Test jigs are something that we are sort of constantly designing and redesigning at SparkFun. We have a QA department whose job is to design test jigs for all of the, you think about a hardware company like SparkFun, we design and release several new products almost every week. I mean, there are several new products every month, and each of those new products needs its own programming and test jigs. And some of those products go on to live pretty long lives in the catalog, which means that those test jigs wear out and need to be rebuilt. We've run into, exceeding the number of presses that a mechanical switch will take in its lifetime. And so a lot of our test jigs now have capacitive touch buttons to start and end tests, because the mechanical switch would wear out before anything else wore out. And so I have been exposed to problems like that, but I haven't personally been the one who's dealt with it. And so I'm learning a lot now about the production side of things that I knew intellectually, right? Like I understood on an academic level that these problems came up and needed to be solved, but they aren't problems that I've ever had to solve on my own before without any of the SparkFun infrastructure or funding or expertise necessarily to back it up. And I'm lucky enough that my boss very much supports my side hustle as it is, and they are in fact, going to be a distributor once the campaign ends, and so we love to see it. And it's been
across all platforms.
Totally. But it's been no problem to I have all these great professional contacts now, and I can ask them like, how do we do this, which has been really helpful. But there are a lot of things that you just do not, even if you sort of understand how hardware is made and marketed and sold, there are surprises, especially sort of all I can think and talk about now is compliance and like regulatory surprises. But that, it's all sort of to do more with making a lot of a thing, and then how the rest of the world reacts when you want to move a lot of a thing from one place to another.
Yeah. And that moving thing is really interesting as well, kind of the logistic side of things. The design, the further I get into this, like the production side of it is so enormous. Production, testing, logistics, like the actual design is just, it feels like increasingly like a vanishingly small part of actually doing it, You've made this great device, and then you've got to do everything else to bring it to market, and everything else is a big bucket, and it's got a lot of things in it,
Absolutely. I mean, that's why you see, some of these companies like SparkFun and Adafruit, where they have this, very like dedicated and enthusiastic founder who likes to design hardware, and then a couple years later the company is 100 people, because if you design a bunch of hardware and people want to buy it, it turns out you need 100 people to support that endeavor, because once people start buying things from you, the designing of the thing becomes by far the smallest part of the enterprise.
And I think a lot of people who are getting into this just really don't realize that. They think, here's my device, and all I have to do is like put it on a website, and Bob's your uncle, I'll just sell it.
Done.
Done, dusted. It's there's so many other things to it.
It is interesting, because I think to some degree crowd supply almost makes that possible. I mean, there's enough support from your end that if you have a design that you want to sell, I think as long as you're willing to put in the work, there's enough guidance to get you there. But the work still has to be done for sure. And
it's still, we do a lot of hand holding for engineers. That's for sure. But you still need to do work. You still need to like know who you need to talk to buy your product. You still need to like make the decisions, right? You know, we do shepherd you a lot through the GitHub. Have you found because we use GitHub to manage all of our campaigns, which lots of people really like. Did you enjoy it, or was it?
It took some adjusting to, because I have never managed I don't come from a software background, so I've never been involved in a project that was sort of primarily managed through GitHub. I've worked in a lot of project management paradigms. I've done Scrum. I've done all of that stuff. We've used various softwares over the years that people are familiar with, and I would say that GitHub is a surprisingly good platform for this sort of thing, where a lot of the interaction that you have with, like, during the campaign, a big part of the campaign is content generation, because you're creating this catalog entry, right, basically, and then you are updating people. And so it makes sense to sort of center all of the discussions around these documents, whether they are behind the scenes documents like compliance documents and data sheets and things like that, or whether they are content like the product description and the photos and things like that. And, having a repository where all that stuff happens totally makes sense. It was difficult for me at first because my GitHub is we already misuse GitHub so powerfully at SparkFun that my setup for GitHub is pretty peculiar, and my alerts are filtered all to hell. And so at first it was like, nothing is happening on this. It's like, well, I need to go check on it actually, because who knows if the alerts about this GitHub repository are even hitting my email. But since I figured it out, it's actually been great.
Yeah, for sure. That's really interesting. All right, let's see what some people have had to say in the jar. We've got Taki B says Heinz should sponsor this, counted beans instead of baked beans. Absolutely. Chipperdoodles, Chip scribbles today, saying production is relatively easy too. It's the logistics that's a big part. Different people have different blind spots. We do a lot of the logistics. Well, Mauser, our parent company, does a lot of the logistics, which helps. But I find production actually I find it one of the most interesting parts of hardware. I'm a bit of a nerd about finishes, so I like seeing how people produce all of their PCBs, because it's just, there's so many different variations, and I just really like enjoying, especially when you get someone like Bunny who do like really amazing production techniques, right, or something. So you get them in and you're like, woo, it's so exciting. But yeah, I love production. Logistics I find fairly easy but boring. And there we are. Here we go. Used to work in production, so I'm definitely biased. So it's easy for you because you used to do it. But no, I agree. It is exciting and enjoyable for me as well. And Leon said the whole business model focused on the maker community and open source hardware invented by companies like Arduino, Adafruit, SparkFun, and RMX is so amazing and inspiring. Yeah, I can't agree more. And Taki is saying, tinkering with electronics since 1978, it's incredible how comfortable things have become. The only drawback is that parts become less and less visible. It's true. You have to get the microscope out for some of them. Yeah. All right. Well, thanks for chiming in, everyone. So, how far are you away? Like, what's we've been going on and on about the things that you've been doing. So, like, do you feel like you're nearing the finish line at all? Like, what's on your plate for the next month or so?
Yeah. So all of that is the timeline is pretty contingent on the results from the test lab, but I am like 99% confident we're talking about a device that runs at 3 volts at 16 megahertz. It's really an 8 megahertz internal oscillator that's PLL'd up to 16. No signal even near that speed exits the chip. I really don't anticipate that it's going to have any problems with generating electromagnetic fields, but I don't think it's going to create harmful interference. It may be susceptible to interference. I worry a little bit about that, only because it is a product based on sort of bare PCBs, which act as the enclosure for the device. So we'll see how that goes. The reason that I haven't built a significant number of units besides sort of review units and test units is that I worry that there's going to be some sort of mitigation that needs to be done. Something will need to be grounded, or some part will need to be replaced. And then I would need to unmake, 500 units and remake them. And so I'm waiting.
Yeah.
So I expect testing to, I have not gotten the test unit into the laboratory's hands. So, but once they receive it, it will take 3 to 4 weeks for them to deliver test results. Once I have test results, it'll take me 15 minutes to write a declaration of conformity for CE and UKCA. And then I just start building, and I have about 450 units that need to be built for campaign fulfillment. And
is that including your pre-orders as well, or is that just from campaign?
That's including pre-orders. And I have.
Is that including our house order or not? Because that's sometimes.
Yes.
Okay.
It's all in all, I rounded it to about 500 units. I'll probably build slightly over 500, and hopefully I'll have enough laying around that I can do sort of an initial distributor order to other distributors after everybody has received their early bird orders. So that should take a couple of weeks. Right now, the date that I've given everybody is end of May, I believe, is what I said, which still seems pretty reasonable from where I'm standing.
Yeah, we're halfway through March now.
Yeah. So I'm hoping, by the end of March, the test lab will have an item in their hands and they'll be testing. And then, end of April, I can start building. End of May, a box full of BeanCounters is, somewhere.
It's gonna wend its way to Texas,
right?
where the warehouse workers will take it out of the box, put it on shelves, and put it in packages all the way to wherever your backers live. Speaking
of big packages of things, these are the 3D printed portion of the BeanCounter.
I was just about to ask you about that. Yeah. So what have you? Tell me about your approach to the enclosure in general, because I know you designed an STL file.
Yeah. So this is for anyone who isn't familiar with the project or hasn't seen one in a while.
Yeah.
That is the BeanCounter, and the construction of the BeanCounter is 2 PCBs that connect to each other through some standoffs, and then they are sandwiched onto this chassis, which is plastic resin. And this is SLA printed. And this is the final version of the chassis. We had some earlier versions that weren't quite as fancy and had some mechanical issues that needed to be resolved. But this part is really fundamental to the way that, it solves a lot of problems for the BeanCounter. So this chassis by itself, you can see. I've got
a question from the audience, someone said the 7-segment displays that you showed just then, are they built in as part of the enclosure? But they're part of the, Chipperdoodle says they're part of the upper PCB, right? But then you've got, on the enclosure, you can see, it'd be useful to show, can you show the different components that we have? Perfect.
Yeah. So on the bottom PCB, you can see that I have the 7-segment built out of discrete 0603 LEDs, and those are driven. You can kind of tell the circuit topology just by looking here. I've got 3 MOSFETs that correspond to 3 digits, and then I've got 7 current limiting resistors, right? So the idea is that I'm scrolling through each digit and then lighting up each segment in that digit one at a time, and using persistence of vision to drive the effect that they're all lit. And so the top portion of the PCB is missing a metal layer and a silk screen and a solder mask so that you can see all the way through it. And so if I, shine a light through the back of the PCB, you can see that the light comes right through those segments. And then I've experimented. It's a really
clever trick. It's a really clever little trick. I like it a lot.
And it's becoming more and more common. I'm seeing more
I've
conference
seen it on a few
badges and synthesizer modules and things like that. And I've found that in order to make that effect really work, it helps to have a spacer in the middle as a mask to separate the segments from each other, because otherwise there's too much diffusion from where the LED is to where the front of the display is. And even if you use PCBs in between with holes milled out, you can find that there's diffusion sort of through the middle, right? Because even if it's sort of solid PCB like this, light will enter the PCB here and diffuse through this middle layer and light up segments over here. And it makes the contrast pretty bad. And so you try to sort of control as much of that as you can with a layer and a mask layer in the middle. So that's one of the things that this does.
That's in the middle. So there's two pieces.
Yes.
I see. So you've got you've got the top PCB, you've got the sandwich, which is helping to make the numbers crisper. Then you've got the top layer of PCB, which is, well, not see-through, but semi-transparent, so that you can see the LED shining through, but it's nicely diffused. Right. And then you've got a fourth 3D printed piece that holds all of the pieces together. Have I got that right?
No. So the pieces are held together by pins that are soldered through. Here's on the final unit. So you can see there's I'm mirrored on my display, which I'm not used to. Four pins here, 3 pins here, and then 4 pins here. These are what are actually holding the unit together. These solder joints.
Oh, I see. So it's not. There's no lip on the PC on the 3D printed piece. It's literally just a sandwich.
It's just a sandwich. The edge of there's a ledge sort of that the PCBs sort of snap fit against, and so there's nothing you can sort of catch your nail on here, but there's also nothing above that point to sort of grab the PCB. They're held together by the solder joints.
That's pretty slick.
Generally speaking, you don't want to use solder as a mechanical joint, but in this case, it's really working as a rivet where you would have to pull the entire solder joint back through a via that's too small for it to even start to take this thing apart. I will say it is a strong enough mechanical connection for this application. And it's also an electrical connection because the top PCB has IR LEDs, infrared LEDs on it, and the bottom PCB has infrared photo interrupters or photo transistors, which forms a photo interrupter, which is how we do the counting. So the power is delivered to those emitters by the pins that go through it. And yeah, this comment about keeping the light contained and using a black spacer was actually a whole thing with the 3D printing suppliers, because a black spacer turns out to be pretty critical, because if you use white, it still diffuses a lot of the light around in the white plastic, and then it doesn't work as well. And it even gave me some problems on the photo interrupter end. And so our original units, our prototypes were all this white. And
really? I remember.
Yeah. And so I have white units sitting around, and there were 2 problems with this. One was what I just mentioned about light containment, and the other is that this has been sitting on my desk next to a window with full sunlight, and this is what happens to those white resins in full sunlight. There's really no way around this because the resin is cured with UV, and the way that usually happens, as far as I understand it, I'm not a material scientist, is some sort of free radical generation from UV that starts the polymerization of the resin. And because that's the mechanism you're relying on to polymerize the plastic, you can't get rid of all of that activator in the finished product. And so it's going to sit there and keep creating things as it sits in UV light. And it happens to all of it, but the white, it shows, and the black, of course, only gets blacker. So that's fine. But yeah, so we partnered with, I partnered with WeNext, which is a service. Yeah, they are. I found that they were suggested to me by another maker, another sort of small company who use them to make some enclosures. And I find they are super fast turnaround time. Their print farm is located in China, but they're fast to get on the project, and the shipping is quick. The prices are pretty reasonable, and they they're predictable. The pricing doesn't jump around a lot. And so it's really easy to forecast what the project is going to cost. And I've also found that they are really responsive to email, which can be a challenge if you're working with overseas suppliers. And so having somebody who checks in on the project and answers your questions and is willing to try some things, even if they don't think they're going to work, is really nice in a supplier, especially a 3D printing supplier where they're very concerned about yields because they don't want to waste resin. But at the same time, you may be pushing their abilities just a little bit, and with feature sizes and things like that. And I like when a supplier is willing to do that for you. So.
Yeah. I'm keeping on plastic. So Chipper said the BeanCounter and my amulets. By the way, your amulets arrived in the office. They are here in the next room over. So I've had a look at them. They've gone to our photographer. So thanks for sending those in. They're sandwich design buds. We love a bit of sandwich design bud. And I like the Predator muscle arm bicep handshake.jpg. Yeah. We love a sandwich design. And he's also got questions here. What plastic are you using for the spaces and what process? The 3D printed parts, right? They are they PLA? Are they resin? Or like what's have you?
They are resin. They're printed on SLA design.
Why did you decide to go that way? Was it purely this company or?
It is because the I don't want to say the sort of the standard way to do something like this would be with injection molding, and injection molding is nice for this type of part, and it gives you more freedom with the material that you can work with. But there are a couple problems with it. One is that this design in particular has transverse, has these holes that have a really high aspect ratio that go all the way through the part in 2 axes. And this design in particular has these sort of like layered holes where they're rectangular at the top and then round at the bottom. And that is to create an aperture.
It's struggling to focus. Can you put your hand behind it?
Makeup tutorial.
Beauty blogger. Yeah, exactly. Makeup tutorial. Perfect. Yeah. You put that. There we are. We can see some of the holes a little bit better.
Poor thing. Does not want to focus.
It wants to focus on your face. That's why.
Yeah, I've provided high contrast lines on my face for it to focus on.
Yeah, it's like, ooh, there we are. Look, it's got some great. Yeah, there we are. We can see
so now maybe you can see those holes are super what you would call high aspect ratio, which is that they are small in diameter but very deep, and that creates a challenge for injection molding where those things need to be pins basically that go through the design and hold space. When the plastic comes in, you pull the pins. And the fact that they are in 2 separate axes means that the mold has to have a lot of what are called side actions, which are other parts of the mold that need to release in a order in order to release the part from the mold. And the more side actions you have, the more complicated the tooling is. The more complicated the tooling is, the more expensive it is. And I have done some design for injection molding in my day job, and the initial capital outlay for tooling for injection molding is thousands of dollars.
It's a lot,
And for a part like this, I to go to a Chinese injection molding company and have them design tooling for this, if I adjusted it so that it would meet specs for injection molding, I think maybe we could do it in like aluminum, because I'm only going to pull a few thousand parts out of it, and then we get away with that. And then maybe I would be looking at around or just over 10 grand for tooling. But if it was a proper tool steel mold, it's $20,000 or something. And the upside to that, of course, is that each part you pull out of it after that costs, 20
very
cents.
little. Yeah. But you've got to be at a certain point before you can start really looking at injection molding.
Exactly. If your tooling costs $10,000,
and your piece looks really professional. It looks great.
The biggest concern with resin is that it's going to be brittle, and so I had some worries about that going into it, especially because the original design has this sort of large unsupported loop on the end, which is where the buttons. So on the BeanCounter, there are 2 buttons on the top surface that you press just like this. And what's actually happening is that you're pressing on a piece of PCB that flexes like this, and it's pressing on a tongue built into the plastic, and then that tongue is pressing down on a micro switch or on a tactile switch. And I worry about that courtyard was going to be too brittle, or that those tongues were going to be too brittle, but I have not had any issues with that. I did some testing, literally just putting together bean counters and then like dropping them and throwing them around to make sure that they survived. And because of the way that the whole sandwich sort of supports itself, nothing can bend enough that it exceeds its elastic limit. And so even though it is true that resin prints are a little bit brittle and a little bit UV sensitive, for something like this, I actually find that it's super reasonable. And on top of that, the pricing is not bad at all. And I wish I could remember what I paid per unit for these, but it was on the order of, a couple bucks a unit, $2 a piece, maybe something like that, which is approaching injection molding prices. If you own, if you pay $20,000
certainly small
for the
scale,
tooling, and you only pull a few thousand parts out of it, it's very easy for something that costs, $20 per enclosure. So I think I haven't seen very many people do it. We've only just started to do it at SparkFun, is to create enclosures and have them sort of commercially manufactured as 3D printed objects. And we'll see how they survive out in the world, being put against the same environmental stresses as injection molded ABS and nylon and things like that. But in the meantime, I'm pretty confident that it is a good way to do complex plastic design in relatively small quantity.
I mean, and particularly because you've got the sandwich design, right? So the PCB is giving it extra mechanical strength, So I think it's a really good solution for this project, which Leon also agrees with. And also, Leon, with that comment, you are today's winner of the live stream giveaway. So you win a bean counter when they hit the shelves. So just let us know. I know your email address, so I can add you onto that. So congratulations, you win a bean counter. My headphones are beeping, so if I start fiddling with the headphones, that's why. FYI. So well done, Leon, for winning the bean counter. We'll get that sent out to you when it's here. Got a few more questions here from or comments, I should say, that Taki B said, we already said SLA gives you the smooth surface and the results look really professional. I'm impressed by the blackness of your spaces. My own experiments return opaque results. And then, agreed, the spacer looks great. And then this is a good point from Leon, which is figuring out a way to make a nice case for low to mid-volume manufacturing is always a challenge. I agree. I hope things will change in the future. Yeah, I mean, I think that this is a really nice way of doing it. The sandwich thing with the SLA. I've seen people offering SLA print at home files or CNC'd milled aluminium. I've seen that. People seem to like that. Like the Glasgow campaign did that, and then Timon's Pionera did that. It's tough, right? Once it's like packaging. Well, I mean, it's tough to find really nice casing. Yes. One piece of advice that I will give some people is, if you've got if you're designing to a standard size casing, there are many, many, many different off-the-shelf cases out there. And if you choose an enclosure and then design your PCB to fit in it, that's one way around it, I guess. Some people do.
If you want to,
have you got any advice?
I would say just, if you are interested in what's possible with a sort of an off-the-shelf enclosure, go and look at the guitar pedal, effects pedal space, because they have really standardized on a few, they used to be steel, more and more they're aluminum enclosures, a very simple soap box enclosure. And the form factor for a guitar stomp box effects pedal has basically settled on a soapbox enclosure with a single or two stomp switches on it and some potentiometers, but they've differentiated themselves from each other by doing all sorts of things, from screen printing on the top to I saw one recently that I think had some sort of 3D printed like embossed text on the top. It was like a thing that was incredible, and
You're
people
right.
would do all sorts of things. They'll flock.
I've not
the
kind of
outsides
made that
off them.
connection before. Yeah, there's so many awesome things we can learn from the DIY and like indie electronic community and music. You do, like when you go into the stores, they've got all these the screen printing, the stunning like different fonts, like really nice different methods of applying things, like gorgeous buttons too often. Yeah, actually, it is a very inspiring space to go and look at cases. Yeah,
and also
another Jibberdoodle also recommends that. But Andrew says Hammond is always a fallback for off the shelf too. They do a big variety of nice ones, although they are pricey for production.
Yes, we've found that at SparkFun. We have a few products that we designed around Hammond enclosures, and then we ended up buying. Usually they're sort of extruded aluminum enclosures that have what are called rails to slide PCBs into. Yeah. And we found that they're too expensive for us to hit the price point we want on our products. And so we end up getting sort of like knockoff Hammond enclosures for the full production run. But Hammond does make, I mean, the common guitar pedal enclosure these days is, I think, based on a Hammond enclosure. It is like, that's the old school classic little metal box, and they're great. And you can see a lot of differentiation between products, even though they use sort of the same basic thing off the shelf. And then something that we have experimented with at SparkFun is taking a pretty simple plain looking plastic enclosure and having stickers made to put on them that can do various things. The stickers themselves might have windows in them for LEDs or labels for, just sort of like a nice graphic wrap for this plain object. And so there are ways like that to get around doing a completely custom enclosure for something and still have something that reflects sort of like the vibe, right, of the thing. Because otherwise, you could take almost anything and put it in a black plastic enclosure and it would still work, but it doesn't, like, that's not a product really.
Exactly. I think we've been talking about that quite a lot today, about the different, about all the different things that you need to add on to your little piece of engineering to make it into an actual product. The logistics, the testing, the casing, the documentation, which we haven't even touched on. Like, how's that going? And how's your software going? Or is it fairly simple? Is it all done? Or
the firmware that runs on the BeanCounter is finished, except for a few tweaks that I would like to make that I just haven't sat down and done yet. It's that thing where it's like such a simple modification that needs to be made that I keep thinking, well, it'll take 5 minutes. And of course, I'll go to do production and realize I don't have production firmware and I'll need to actually do it. But for the most part, I mean, the test units do what the completed units are going to do. They all turn on and they all count components. And it's, it wasn't a huge programming challenge. I'm pretty happy with how stable it is. I'm pretty happy with how the UI works. So that's not so much an issue. As far as documentation, I'm a huge fan of having documentation on the product as much as possible. And so on the back side of should focus on this.
What, you've got nice silk
so
screen.
On the back of the PCB, it has sort of the basic user interface directions. So it's how to pause and resume counting, how to do the basic setup for the device. And then it points you to the complete docs, which are at the GitHub repo for the project.
That's great.
And those docs are there right now. There's a wiki on the GitHub that has sort of the basic operating instructions, but it doesn't, I don't have like a nice graphical data sheet or anything yet, but I do plan on putting that together. And then of course, to meet regulatory requirements for CE, there need to be printed directions included in the packaging.
Oh, really?
Yes. So those printed directions need to be supplied in, I think, at least 2 EU languages. And so I will do them in my native English, and then I will maybe pay somebody to translate them to German.
German's a good call.
Yeah, as much as I would like to just plug it into Google Translate, I know how that goes down, and I don't want to be that guy. So
in Europe, the Netherlands, Germany is definitely the biggest market outside of the US and Canada.
Yeah, my understanding is that if you can get English and German on there, then you've covered most of your bases.
Yeah.
Which is funny because there's
the French like to see the
such
language,
related languages.
Yeah.
Like from a linguistic standpoint, English and French is probably is a better call, but whatever.
But if we're talking about the languages that predominantly used in the spaces where you're going to be selling things into, I think English and German is a good call.
Yeah, and so I will have to probably take the wiki and lay it out in a nice way into a big. This is why every time that you buy a piece of electronics, you get that big piece of boilerplate that's a big fold-out thing that's folded into a tiny little square.
Yeah,
and you're like, why did they put this in here? Yeah, that's what it's for. That's regulatory compliance. So, to some extent, I will have one of those in the package as well.
Dope. All right, we've got some questions more. So going back again to the case, people are still talking about that. I'm saying fitting into an existing off-the-shelf case is a good option. The disadvantage for me is often these cases are not open source hardware certified, and this is a showstopper for me. Interesting, Leon. I wonder if there are any cases out there that are certified. Like you're talking about the actual mechanical design of it there. Yeah, that's interesting. Yeah, because I know there are many mechanical designs that are open source as well. So there's a niche out there. Leon's asked, what do you think about laser cutting metal and bending it for an enclosure? I'll do all the closure ones together, and then you can comment if you've got anything. So Andrew said a laser etched acrylic panel glued over a smooth aluminium surface is one thing I've experimented with where I wanted text or graphics. It gives a nice kind of dimensional effect. Oh, interesting. So drop a link to that. I'd be interested in taking a look at what you've done. And then those are the enclosure questions. Any comment on laser etched, laser cutting, or acrylic versus metal? And have you come across open source enclosures before?
That's a good question about open source enclosures. I have not come across open source general purpose enclosures. I've come across projects that had their mechanical drawings under an open source license, but they were very particular to that project. I have not seen sort of a Hammond-like collection of enclosures that meet OSHA. So that would be a very interesting thing to see. And as far as cut and bent sheet metal for enclosures, I actually really like that. I, for the first time ever, had some parts cut and bent from aluminum for a project I'm working on, which is an open source glass blowing lathe.
Oh.
And I needed...
That sounds exciting. Very niche.
Yeah, incredibly niche. And even in the world of glass blowing lathes, this one is particularly niche. It's very small and it's designed for small work. And
like bead work.
It's essentially I have been working on
with these fewer tubes.
my vacuum tube project.
Nice.
And this is the tube that I showed off at Hackaday Super Conference.
If you haven't seen this talk, you need to go and so there's at SuperCon, this one that just happened in 2022. Nick did a great talk about exactly what he's showing off there, which are these DIY like vacuum tube, open source things of curiosity and delight.
So in trying to build this lathe, I wanted a inexpensive way to create something that was very structural, and I ended up designing a piece that was made from 1/4 inch thick aluminum and then bent into shape and then bolted together. And I had the entire process done by not Send Cut Send, but Oshcut. Those are two different companies that both do this sort of thing. And I am ecstatic that service exists and that it's relatively affordable. And I think especially if you have the capability to bend metal yourself. If you have like a sheet break or something like that to bend sheet along a specific line, then you could make a lot of very high quality enclosures in a very small amount of time, even if you outsource just the cutting of the sheet metal.
Yeah, and actually, I remember Oshkosh, Oshcut. Sophie Kravitz used them for a project recently, and she said that they were great. Yeah, you just get these great stencils pretty quick. Not that expensive either.
Yeah.
Very exciting. All right, more questions. I can hear myself. This is with these headphones. It's horrible. So Tube Time US. Hello, nice to see you. Thanks for turning up. What are you doing about text fixtures? We actually did speak about test fixtures quite extensively earlier on in the stream, so you might want to rewind and listen to that a bit more. But unless you have anything else to,
I mean, essentially, what I'll end up doing is creating sort of a 2-layered test fixture out of PCBs that has all the electronics on the bottom and then has sort of a stage on top that you'll sit. I'm hoping to sit the entire sort of panel, which has 2 BeanCounters worth of PCBs on it, sit that onto a thing and hold it down. I'm not going to do any clamping or anything fancy like that because programming on these is very quick. So it'll have an AVR gang programmer on it to program 2 of these at once. And then that's basic. I'll use pogo pins to engage the ISP. I have a 6-pin, where is it in relation to the camera? 6-pin AVR ISP connector on there, and I'll engage that with some pogo pins.
Nice.
And yeah, just program it and then upload the firmware, and then I will just sort of visually confirm that the IR LEDs are blinking, because if I look at them through a camera, I can tell that they're illuminating. And then after that, they will get an actual strip test where I, after each one is fully mechanically assembled, I will turn it on, pull a piece of cut tape through it, and make sure that it reads the number that I'm expecting. And so the testing is going to be like true unit testing, and then the actual sort of basic programming will be just a very simple pogo pin test programming fixture. And then as far as assembly goes, there are some things that I'm designing for assembly. I need some sort of jig, which will probably be 3D printed to help hold all of the pieces in relation to each other as I do the soldering. And then I'm also working on a tool. This is a prototype for a tool that is basically like the click mechanism for an ink pen, but instead of ejecting the ink cartridge, it will eject, it will basically treat a strip of pin headers like a strip of brad nails. And so every time that I press this button, a pin header will be ejected from the strip, like and that will allow me to very quickly sort of go pop, 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 and drop pins into these things, because that is the you've made yourself challenge. Yeah. And I don't know if it works yet because I have this 3D printed part of the prototype, but I don't have the other piece of it built yet, so I can't see. But the whole, I mean, it's pretty simple. I don't think it's one of those things where if it's not simple, I'm not going to spend too much time trying to troubleshoot it, because I can just do it with tweezers.
Yeah, exactly. Well, we've got a few. Tube Time says this is very interesting to me. Good. And Taki says self-made tubes, something I want to try myself. Absolutely. We didn't actually get any time to talk about your self-made tubes, even though it's been an hour already. Would you like show one of your self-made tubes and just tell people a little bit about it?
Yeah,
a couple of minutes. I just think it's
give you just sort of the elevator pitch. So this is a tube that I built. Excuse my dirty fingernails. This is a vacuum tube that I built. It's a diode.
Blogger hands.
Yeah. For Hackaday Super Conference. This is the first tube that I've built that actually is properly evacuated. You can see that the getter material, which is what absorbs any excess oxygen that might be in the tube, is still silver, which is a good sign. It means that the tube has stayed sealed since I built it last year. And this has a tungsten filament in it that glows white hot. And then once that filament is glowing, I can pass a current in only one direction from the hot filament to the cold plate and not the other direction, which makes it a diode, sort of the original diode. You'll notice it's which is, I mean, the word diode is for 2 electrodes. So it's a tube with 2 electrodes.
I did not know that.
Yeah, and
That's
so
delightful linguistic electronic facts.
Yeah. So I had the little, you can see what do they call this? The Jolly Rancher Hackaday logo in there. I had
really
those
designed that, I think, didn't he, from Made of Fruit?
Yes, he did. And I had this cut again by Oshcut,
Nice.
out of nickel, and it's
the tiny bit in the middle that was also Oshcut.
Yeah.
Oh wow, they do really small things as well.
They do.
Oh wow. I need to get myself on Oshcut, clearly.
And then I have an entire if you're at all interested in this, I would say please go check out the talk that I gave from Hackaday SuperCon, and then follow from there. Sure. If you're still interested, you can check out my YouTube channel where I've been keeping super precise notes about this process, which involves all sorts of fun high vacuum equipment like turbomolecular pumps and ion gauges and all sorts of sort of material science, particle physics nonsense.
Yeah, amazing. And that's on your YouTube?
Yeah, that's on Signal Ditch, YouTube. YouTube.com/C/Signal Ditch.
Signal Ditch. We'll put the link in the show notes. So, well, we've gone over our time by nearly 10 minutes, but it was really, really, really nice to talk to you. I could always talk to you for a long time. I'm sure we'll have you back on once you're fully delivered and working on your next project.
Sounds great.
Once this one's done. Thank you so much for joining us. Stay backstage because I need to talk to you about a special thing. Oh, I can tease this. Okay, I'm not allowed to announce it, but I am going to tease the fact that in the next day or two, maybe early next week, we're going to announce Teardown, which is Crowd Supply's annual conference/festival, and it will be happening this summer. Details to come, but yes, that's going to be announced in the next week or so. Also, for those of you who are local, some people who are local do watch this show, I'm on the 28th of March, I'm going to be running a new sound and audio event for hackers here in Portland called Sound Hackers, and you can find that on meetup.com if that's your genre of interest and you are locally based. Next week on the Teardown Sessions, we will be talking to Ukama, who are an open source group who are making their own cell phone towers. Very interesting. I don't really know much about that technology, so I'm really excited to learn more about that next week. Thank you all for joining us and keeping us company with your comments and your questions, and appreciation particularly for Nick and the amazing work that he's been doing. Thanks, everybody. See you again next time. Okay. Bye. Bye.